Hello. Good. इसको स्टॉप करो, स्टॉप अभी क्या करना पड़ेगा बताओ, फ्रॉम वीडियो
को कौन कर रही है? वह उत्पन्न
Hello. No, just one second. Right now I'm hearing, but you have joined already. From there you can talk. Please. देखो लाइव स्ट्रीम चल रहा है नहीं चल रहा है इतना देख
रिकॉर्डिंग तो कर दी।
लाइव स्ट्रीम को देखो, यहाँ से देख सकते हो।
देखो रुको एक मिनट। हाँ
स्टॉप नहीं करना, यहाँ से देख लो चल रहा है नहीं चल रहा है। बालाजी का है देखो इसमें।
नहीं वो छोड़ो, आप छोड़ो, चलो
हाँ, गुड मॉर्निंग मैडम। We are not getting your. Good morning, madam. Your voice is not coming. Hello.
टॉपिक क्या है?
ठीक है, ये 3 day ऑनलाइन ट्रेनिंग ऑन सच 3 day
प्रोफेसर ज्योति एम के लिए
उनका लेक्चर है। हाँ मैम,
अभी का टाइम।
हेलो। No, voice is not audible and not at all it is coming. Now your connection is been detached. Hello. No voice is coming. लाइव स्ट्रीम चल रहा है ना?
मैं देख रहा था, मेरे फोन आ गया। मुझे टॉपिक
दे देता हूँ।
बदलो आप, कोई बात नहीं। कौन सा है?
3 day ऑनलाइन का। हाँ,
तो अभी 2 लाइव दिखा रहा है, तीसरा डिजास्टर किया।
Yes, madam, you talk. Let's see. No voice is coming.
Hello. So is it okay? I am audible now.
Audible, madam?
Yes. So it will be like I'll be talking from my mobile and will share my PPT from my desktop.
Yes, madam. Yes.
Okay.
Now, after 2-3 minutes, I am going to start. Okay, madam. That
Yes.
some more participant has to join. Hardly now. Right now, only 25, and another 2-3 minutes. We'll wait. Then we'll start it.
Okay. Fine.
I am audible properly, na, madam?
Yes.
Okay, no problem. And you do whatever you are said in that ingenious way. Please manage it.
Yes.
But sharing is not the problem now.
Sharing, I will just try once.
Okay, I'll do it. Initially, I'll come, then some recapitulation of yesterday's program. So for that, like this, 5-6 weeks will take. Then I'll read your biodata. Then program will start. Then you your lecture.
And after that, I will share my PPTs.
Yes. For sharing, I'll do here. Then you. Okay.
Okay. Fine.
So okay. पीपीटी है इसको तो हम यहाँ से शेयर करके Good morning. We are going to start the session now. Already panelist is in the line. So again, I welcome you all the dignitaries and learned speaker and dear participants. It is giving me privilege that to share the yesterday's proceedings, what is happened, and what was the curriculum one by one. I'll read it to make aware to you all And today is the third day and final day. Today we'll be having two lectures. First will be taken by Professor Jyoti Swarup from Manit, Bhopal. Thereafter, I will take one class. And Professor Jyoti, she will take the class on flood study and some case study. She'll be showing in South India as well as also regarding related to flood. She'll speak something. Thereafter, I will also take, that was also the climate DRR. Today both are on flood topic. And before that, before today's program start, I will tell you, yesterday there were 4 lectures, and first was taken by Mr. Harihar. He is our colleague from NIDM. He took the class on innovation, DRR and R, where he talked that remote sensing and GIS that will give lot of exercise for the disaster work, aerial view, and that UAV, they are giving lot of critically critical information for large-scale mapping and community-based disaster risk reduction, and it can give also the hazard mapping. Thereafter, Professor D. Srinagesh, he is the chief scientist, retired from NGRI, Hyderabad, presently who is working in IIT Madras. He talked about earthquake hazard studies. He explained how India is vulnerable for earthquake and why, what are the basic reasons. He described the statistics of all over India, what is the economic losses, what are the fatalities for Indian and other country also. He said that every year, at least 1 lakh earthquakes are taking place in the earth. And also, severe, for the last more than a century, what are the big severe earthquakes all over India? He has given an account of that. After that, third lecture was started, and it was for the landslide purposes, where Mr. Anil Kathait, he is also our junior consultant in NIDM. He talked on the topic landslide risk reduction and resilience. He appraised that the different landslides in Himachal Pradesh region, in Kotrupi, landslide was very serious. And what are the fatalities? He explained in detail. Also economic losses and livestock, what are the severe things happened and severe losses were they highlighted, where he said 46 people are died and agricultural lot of damages were there. Thereafter, Professor P.K. Verma from Ujjain University, he talked about climate change education for next generation. He narrated in details about the present generation students' status and lifestyle in school, colleges, and houses. He also talked about the student psychology nicely. Briefly, he explained for the students and present generation. Now, with that, I will start for the today's program, where Madam Jyoti Swarup, she'll talk about the flood. She'll show his slide after some time. Before that, I should appraise you regarding his career, his regarding what are the things, past experience, and how much learned he is. I should make aware to you. So basically, she is in the line applied geology, remote sensing, and GIS. Her area of experience in geology, digital photogrammetry, microwave, and hyperspectral remote sensing. She is PhD in water resources development and management in Raipur district, MP, using remote sensing and GIS during 1995 to 98 from Barkatullah University, Bhopal. She had her MTech in remote sensing as digital remote sensing from 91 to 93 from same university, Barkatullah. She is MSc in applied geology from Holkar Science College, Devi Ahalla University, Indore. She had 23 years plus professional experience. She was during 1993 to 99, she was lecturer in Barkatullah University, Department of Applied Geology, where she taught about applied geology, MSc Tech and remote sensing and GIS. She was scientist from 1999 to 2006, Center of Studies in Resources in IIT Mumbai, and taught MTech, NRE and guided projects, research projects and consultancy. And from 2006 to 2010, she was faculty head in Rolta Academy in Mumbai, Andheri. And job was assigned in-house training on geospatial domain, live project, specific timings, and recruitment purposes also. Presently means since 2010 onwards till date, she is professor in civil engineering department, that is in Manit, and she is teaching engineering, geology, remote sensing, GIS, digital photogrammetry, microwave, hyperspectral remote sensing, etc. She had already guided more than 8 PhD theses. She has guided 2, and 8 guided and 2 submitted, 4 are under guidance. And she had the project experience in 10 big research projects sponsored by DST, IIT Mumbai, Manit, and she had also 16 consultancy projects. In industry experience on best practice and work flow of ant navigation, British Telecom, Kitchener Water, Gas Utility, Nigeria 3D feature collection, A1 and A in digital elevation model projects at Rolta. 60 plus PG projects, thesis she has guided for MTech and MSc, even for BTech also, for the dissertation work. And she had her course formulation NR 643 on remote sensing for subsurface water resources in CSRE IIT Mumbai. Geospatials, another was their geospatial curriculum on remote sensing, digital image processing, photogrammetry, utilities and communication software, tutorials, exercise, hands-on practices, all the things she has done. And she had with her credit more than 60 plus technical papers in different national, international journals, conferences, and symposium. And she had the technical skill in remote sensing, GIS, digital image processing, microwave, remote sensing, photogrammetry, etc. She is well versed in the software, in GIS, and ArcGIS, MicroStation V8, and on-point FGIS, AutoCAD, MAP, 3D, Geomedia, Suite, etc. And digital image processing also. She has used ARDAS, NV, PCI Geometrica, etc. Also, she has experience in photogrammetry, where she used Z/I image station, LPS Suite, Rolta photogrammetric mapper, utility, etc. Other information that 3 short-term courses she has organized, 20 international national seminar attended. She had with her credit a lot of awards for recognition. She got Young Scientist Award from MPCST, Bhopal, and in 1999. In the same year, she has received her Best Paper Award from the Association of Hydrology, India. And during 1993, she had her first position in university, merit in university in MSc Tech and Remote Sensing. She was first position in merit university in MSc Geology. Also, extempore speech during 1988, and best speaker for the seminar during 1988. With this was her vast biodata. With this, I'll close and I'll hand over the stage to ma'am, and I'll request her, she should start her lecture for the benefit of our students and for the benefit of our NIDM. Over to you, madam. No voice is coming, ma'am.
Now it is coming.
Yes, now it is coming.
Okay. So thank you very much, sir, for giving elaborated biodata, and very good morning to all of you. So as sir has already briefed about the yesterday's curriculum and the topics which had been covered, so today I am going to talk much on the application part of the remote sensing, which is an advanced remote sensing on microwave application. So microwave remote sensing application in flood monitoring. So how it is different in case of optical data, and how it is beneficial and convenient in case of the forecasting or monitoring of the flooding, mapping and monitoring. So today's focus is on the application of microwave remote sensing in flood monitoring. So I'm going to share my PPT here. Can you see my PPT?
Yes, madam, it is coming.
Okay.
You can make it zoom. Yes, nicely. Fine.
Okay, fine. So, as the topic suggests that flood monitoring using microwave remote sensing, so I will touch upon little bit on the floods and then how the monitoring is done, what can be the general methodology for monitoring of flood, and how the microwave remote sensing and what are the basic principles behind the microwave remote sensing that I'm going to cover, and we'll highlight some case studies and the tutorial, like sort of if you want to use the microwave data, then how that can be downloaded, freely downloaded from the site, and you can actually process the data and use it for your mapping purposes. So this much part I'm going to cover in my slides. So as all of you may be aware that what is flood, it is relatively a higher water flow that can overtops the natural or artificial banks wherever it is the water is accumulated. So in any portion of that river or stream or any artificial created reservoirs and other things, if a relatively higher water flow that overtops the natural banks or the artificial banks, then we can call it as that the situation is in flood. So wherever it exceeds the limit, then we have to monitor it. We have to, and there is a need of monitoring. There is a need of mapping of that particular area. Definitely, there are certain parameters and relative things which affect and which are responsible for the flooding, which we are going to see in next slides. So it may be a river, it may be a coastal floods, it can be a urban flooding, it can be a flash flooding. Out of these two, the river and coastal flooding were very common, but nowadays we are seeing that due to change in the topography, due to change in the drainage patterns and expansion of the sprawl of the urban areas, the urban flooding is becoming very common, and the last is the flash flooding. So keeping in all these things in view, that how this affect our habitats and livelihood, and other things, and how the remote sensing and GIS, but I'm not going to touch upon much the GIS part, but how the remote sensing data are helpful, and which one is the better one, whether an optical data or a microwave data, that we are going to see today. So in Indian context, we have definitely the flooding, but after the Bangladesh country, we have, or India has the most affected country in the world, and it has accounted for 1/5 of the global deaths count due to the flooding. So it is a very severe one, and which requires definitely, and it requires improvements in the information to be collected, geodatabase to be updated regularly, and to be monitored regularly. It is just because the rainfall is getting very erratic in nature. Yeah, during the last few decades, we had a very normal spell of rainfalls, but after a certain period of time, we are seeing that there is all of a sudden heavy rainfall occurs in winters also, or after the post monsoon. So there is a need of continuous monitoring throughout the year, rather than from the June to September, which was called to be the rainy season in India, especially. So, definitely there is a need of monitoring it, so that the mitigation and other precautions can be taken before or prior, or we can prepare ourselves. So this is the situation which is changing, and definitely remote sensing can help us in giving the information beforehand, so that the planning and execution can become easy. The reason for the flooding, you can say, that is the mostly the southwest monsoon over India, and where in which actually covers the rainy season from June to September. And so generally what we do, we analyze the rainfall data from June to September, and during this particular period of time, if any anomaly occurs or if any heavy rain occurs, then that may be the cause of the flooding. In an average, the rainfall over India is 119 centimeter, with the high spatial and the temporal variation. So, heavy rainfall at intermittent spells causes flooding during the monsoon months. And if we see from January to December, we have majority of the heavy rains which occurs during this period. And um, we expect that mostly the flooding will occur during this period of time. And according to the National Flood Commission, about 40 million hectares of land in India is prone to floods. So, if we talk about this much area in a spatial context, and if we see that the temporal part of the rainfall is during these 4 months, then there is a need of definitely the correlation of the area as well as the rainfall. General causes of flooding, all of you may know, but as we talk about the feature, special feature as river or the coastal region, or then remote sensing techniques can help us out in identification, mapping of the river or the water bodies which are available well before, and wherever the expected heavy rains are there, then we can actually start monitoring it before the June period, or from January to June period, so that special geodatabase can be created, and further the analysis can be done. So, if any river, or majority of states like Uttar Pradesh, Bihar, West Bengal, and Assam, where it is very frequent, and every year, means repeatedly we get the flooding. So in those parts or state level, we can actually use those techniques. The rivers carry a large amount of sediments, causing erosion of the banks in the upper reaches and overtopping in the lower sediments. So any kind of erosional activity which are taking place along the banks of the rivers, or is there any change during that course of time, that can be mapped, and that can be further taken care time to time. So this can be one of the cause of the flooding, and if it is more, then that definitely requires an attention. So mapping and mapping, or you can say any change which are occurring, that can be mapped initially, and if it is exceeding or if the overtopping is there, then that definitely needs further um, measures to take place. Any other reason like drainages? So sometimes drainages also get blocked due to the prolonged flooding, and drainage mapping, morphometric analysis can also be done through, or with the help of remote sensing and GIS data. Then massive indiscriminate deforestation leads to large amounts of topsoil coming loose in the rains, which flows down into the river, and in that turn, it causes the riverbeds and its tributaries to rise. And after that, it is possible that there may be a flooding. So these are all the reasons which can be actually seen very well through the remote sensing data. And if any kind of heavy rainfall or any pattern change is there in the rainfall in that particular area, then that can be taken up for the further precautions, or for further action to be taken. So this kind of action is required from the disaster management and mitigation departments also, a continuous, at least before the rain starts and during the rains, and if there is a receding and preceding parts are there of the flooding, then that helps us. So if we talk about the management, then we do it in these three ways. I'm not going to go into the detail, but flood preparedness is there, in which before flooding, such information can be taken. And if there is any relatively changes in threshold values are occurring, then we can actually take extra care of that. During the flooding, like relief and rescue part, and flood mitigation means after flooding, what can be the plan. So these all three things come under the management, and which can also be um, done by using the um, remote sensing data. So all these things are related to the flooding, and there are techniques available which help us, because during that flooding or after flooding, it is not possible to go into the field. We cannot actually approach to those field areas. Only the aerial part is available. So satellite and aerial photography helps us out in collecting the information. How much is the loss? How much the area has been damaged or has been affected? What is the receding period? How it is moving? In which particular direction it is moving? So all those things we can actually cover in remote sensing techniques. So here the role of remote sensing, as yesterday already the basics of remote sensing has been covered, and all of you are now have got the understanding that how the working principle and processing of remote sensing is. So I will not touch upon that, but the major features of the remote sensing is that it provides us the synoptic coverage, so which helps in the identification area has been affected by the floods, or which part of the river is getting affected. So all those things can be seen through the synoptic coverage, because it has a very large area, like 100 by 100 kilometer swath, or 818 kilometer swath, or we have a 70 kilometer by 70 kilometer swath of a particular data. So that synoptic coverage becomes very, very important feature for the monitoring and mapping of the flooding area or flooded area. We can get the real-time information. Like if I talk about the microwave remote sensing, then microwave remote sensing gives us the alternate dates, like 1 day, 3 day, 5 day, 7 day scatterometers data. And now there are many optical satellite data are also available, which provide us the real-time information. So we get actually what has happened or what is happening, we can see. Then in microwave remote sensing, we have a feature like all weather conditions. So those features can be used for flood mapping, especially in case of cloudy or clouded weather, where the optical data may not be feasible, or it may not penetrate to the information to be given or taken. So all weather conditions is one of the feature of remote sensing, which can provide us the information during the flooding. Then we can have a continuous monitoring with the help of remote sensing. So one or other way, the sensors which are available, we can actually see that
Good morning, sir.
the flooding is is getting preceded. So it provides the flood inundation mapping and monitoring. It has a rapid and scientific base, which can help us out in damage assessment. It can help us in monitoring of flood controls, changes in the river courses. So what was before, what was during, what was after, that can be mapped. So change detection can be mapped. Then identification of riverbank erosion, that can also be done through the help of remote sensing. Then identification of chronic flood prone areas. Then we can actually have some other parameters, and we can use those parameters for hydrological and hydraulic modeling. Then improvement in flood forecasting, like if we have more databases, then it will help us out in forecasting and warning the things, so that the people and casualties can be prevented. Then rainfall estimation is also can be done with the help of remote sensing. So continuous rainfall analysis can be done with the help of certain model like HRU and SCS. So the process of remote sensing is like, we have a space segment and we have a ground segment in the form of software, and other digital image processing applications are there. We can apply it, and like for you are seeing over here, flood forecasting. So this is a complete process of the acquisition of information, analysis of and implementation. And then so sensors and platforms are required for getting the information, and that can be displayed, that can be analyzed with the help of the processing, data processing or image processing, and it can be used for any kind of application. So for flooding, if we talk, then we can actually go for the national level, like overall India, and then from India to the state level, from state to the district level, and district to the village. So how many um, small parts of the land has been damaged to the particular district and the state level and to the national. So if we talk about the national level, it will be a very wide area, and we can use some small resolution, means low resolution data, like WIFS WIPS data. If we talk about the state level, then also we can go for the WIPS data. But regarding the district and village level, we need certain high resolution data like list 4 or list 3 data and list 4 data. But when we talk about these data, then the season and the clouds and weather conditions become limitation. So to avoid that, we have parallel microwave remote sensing. Although before and after data can be analyzed with the help of optical data, which has a high resolution, but in case of the during flooding, so that for that particular part or getting information, microwave data are very helpful. And why and what are the basic difference that we are going to see. So flood monitoring can be done at these particular levels at different scale and different resolution. So if we see a state-wise flood impact, so we require large swath. If we have to see a very limited area on a regional basis, then high resolution data are generally required, which appear like this. So here we are seeing that the river is flowing with a very thin and the width is very low. But as the flood occurred, this has covered a very large area. So for detailed study, like we have a WIPS 188 meter resolution and its swath is 810. So if we are going for a national level or state level, we can use such data. And for the AWIPS, like 56 meter resolution, relatively higher resolution, but the swath is same. So for state level or getting in detail, little bit detailed information, we can use it. Then list 3, list 4 and pan. So as we move from left to right, the resolution is increasing and the detailed information are increasing, but and swath is decreasing. So area of coverage is decreasing, and we are getting detailed information about that particular area. So here we are able to see that the resolution is coarse and resolution is relatively higher. So we are able to see the pattern and other things which you might have covered in yesterday's presentation. So in this case, for detailed study, which data would you like to see and choose? That is actually one of the important factor in case of resolution and the scale. Then revisit frequency, like you want daily coverage or you want 15 days coverage or 10 days coverage. So revisit frequency is available and we can have daily data. And within a few hours, like morning 10 o'clock we have, so the data can be processed and is easily available next day. Then now for spectral bands, like if we have a red band, if we have an infrared band, so spectral band is also one of the important information which is given in the remote sensing. Like we have water land discrimination or clear land water discrimination or demarcation. So in case of red band and in case of infrared band, so in this particular image, you are seeing that the clarity of the water and land, this is the land part and this is the water, so it is more clearer in case of infrared. So those kind of things can be chosen clearly and we can actually have a better result. This is just because maximum absorption by water and maximum reflection from the vegetation and the land. So with that, we can actually use the infrared portion and the red in combination for band vision. General methodology for flood mapping requires that you have a flood event, like that news comes across, or you see that the heavy rains are occurring, like even previous month also, last month we got that heavy rainfall occurred in the northern part and the middle part and UP and other places. So we need to be aware about that, how the season or is getting the rainfall or receiving the rainfall. Then collection and compilation of water level for different rivers, that can be done prior. Means preparedness, we can prepare the last few years data. Then satellite coverage charts, like which will provide us the daily coverages or at least 2 days coverages. है ना? So those kind of things can be taken prior. Then preparation of gauge hydrographs also we can collect. So all these things we can actually keep ready in, if we are doing any mapping or the monitoring of flood or the frequently occurring monitored areas. Then optical satellite data on daily basis procurement, like you want to procure the data, or if it is cloud free or if it is not cloud free. So those kind of collections we can actually do, yes or no. Then water level above the danger level. So if it is yes or if it is no. So in case of optical satellite data, if it is cloud free, data is cloudy or cloud free, and if the level is increasing, then that emergency program for radar sets are details are required. If it is if the data is cloudy, then you have to go for the radar set, and then procurement of that radar set data is. So these are the first part of the method, or you can say the approach for mapping, which is generally common for any kind of data we are using. Then second part is that you have to do analysis. Whatever data you have acquired, you have to analyze using the software. Nowadays, all digital image processing software are available, and to some extent, GIS, QGIS also has so many tools to analyze the data, like rectification or extraction of flood layers by different means, like you are using DN value, you are using decibel values, or you are using some customized automated segmented feature extraction tool. So those things can be used over here for the analysis purposes. And maps and the inundation area statistics can be generated, and the data can be created, output can be created for some information or some. It is done using the usually what the identification we can call it as visual interpretation, like you are identifying some changes along the river banks or some other parts, and then you are identifying them, classifying them, and then doing some digital techniques for further enhancement of the information, like slicing, textural analysis, supervised classification, and supervised. So you get lot of information which help us out in the mapping and the statistical calculations. So this is all about the data, how the data of remote sensing are generally used in mapping. When we talk about how the data appear, so it appears like this. You are seeing over here that very small part is visible and everything is clouded. The similar area when we see in microwave remote sensing portion or microwave range of electromagnetic spectrum, then the data are very clear. You can see a river flowing which has a water, and some portion is also, so some dark and light portions are there. Although the interpretability or visual interpretation part is not that clear, but we are able to see the features which are important from the flooding point of view and is not clearly seen over here. So all weather and all time capability is there with the help of microwave data. It is of July actually. Both the data are of July Landsat and the microwave SAR data. So cloud cover problem during the monsoon months can be overcome using the all weather and all time capability. Now, how it happens and how the data are acquired, that I'm going to touch upon a little bit. So, in case of the mapping, definitely the microwave data are helpful. In case of the after the preparedness, means before flooding and during the flooding, when the proceeding and recedings are there. So we can here also clearly differentiate that if we are going to deal with the water content part or the vegetation part or some these land surface discrimination with water, then the in case of remote sensing, microwave range of remote sensing become very, very helpful rather than the optical data. And when we analyze it, then analysis of the event or the functioning will be more accurate than the optical data. So, radar in for remote sensing, or you can say the characteristic of the microwave remote sensing over the optical remote sensing is that it has all weather capability, like small sensitivity of clouds, light, rains can also be penetrated, and the data can be collected. It is just because it has a longer wavelength and it travels slow, and therefore it can penetrate through the clouds, through the small dusty and water vapor particles, and even the rains also, and can give us the information. Then day and night operation, independence of the sun illumination, it does not require any source of light. Although in case of passive it requires, but in case of active microwave remote sensing, it does not require. So there is a minimal temporal variation, like temporal resolution. If you talk about, then it has very less effect. It is very, very sensitive to dielectric properties, like we have a water content, biomass, ice, and therefore it becomes important for the flood mapping and monitoring. It is sensitive to the surface roughness. So these are the properties which are dealt with the microwave remote sensing, and it provides the difference in the value of dB. dB means the decibel. Like in optical data, we use digital numbers. Whatever the intensity of reflected energy is recorded, that is processed in terms of the digital number, and that digital number is displayed onto your monitor. And with the help of those digital numbers in binary bytes of 2 to the power 8, 2 to the power 4, 2 to the power 6, we identify the objects and we see that what is the maximum reflectivity from the object. But in case of microwave remote sensing, we have that what is the dielectric property of that surface, and what is the characteristic of the surface. So if very high velocity of wind is there, waves are very high or low, so thus it will give the change in the surface roughnesses, and that will be identified and recorded in terms of the speckle noise. And then by these speckling, we actually process the data, and then we find it out that what was the condition at that time. So these are very sensitive, although but very complex in the interpretation. You have to understand the relationship of the wave which is targeted and is being recorded, and what can be the change in the mode of the acquisition at that particular time. So phase and the time of the receiving and transmitting energy becomes very crucial. Then sensitivity to man-made objects like very large reflectors are there, or nowadays we are using solar panels. So all it is very sensitive. Like it can actually give us the change in the dB value. So all these things become the feature and specification of the microwave remote sensing, and two or three we can use for the flood map. So here you are seeing that the difference between the microwave and the optical data. So they are sensitive to the terrain, surface, and the properties of the surface, and accordingly it provides the information. Here you are able to see that the change in the gray colors, and here you are seeing that there is a change in the tonal. So optical data are more sensitive to the amount of reflectivity, while the microwave data are are sensitive to the surface change or any property change, and that is the fundamental difference in both the technology. So here you can again further discriminate that this is the list 4 data and this is the reset data. So here in case of the surface ruggedness and surface roughness is very highlighted, and here one of the river pattern is totally like we can say that missing, but here it is being clearly visible. So in case of water land discrimination, in case of vegetation water discrimination, we should actually go for the reset data. Now why and how, I'm going to show you. So some of the basics of microwave remote sensing, which are little bit different than the process of acquisition of the optical data, like you might have studied or you might have read from the net or books, that the amount of incidence, radiation, and the amount of reflectance, and that actually governs, which is known as the spectral signature, and that defines that whether it is a water body, it is a vegetation or desert or glaciers or major resources which are available on the surface, and with that we identify the features. But here there is a difference in the characteristic of the propagation of the wave, and in this case the remote sensing technology has very well used the change in the characteristic of the electromagnetic spectrum wavelengths, if it is a faster, if it is relatively faster, or if it is slower. So those conditions and the characteristic which has a difference in behavior when it is interacted with the objects. The similar portion of visible part of electromagnetic spectrum will behave differently with water, and the microwave region will behave differently. Because of this basic principle, like we have a velocity is equal to n lambda, or frequency into lambda, and here in case of the microwave remote sensing, we use the frequency cycles per second, which is measured in hertz. So generally we do not use the wavelength in meters, but we use that how much uh, uh, cycles per second that particular energy has come across with the object, and that has been recorded by the sensors. So that this is because of the nature of the change in the frequency, we get that there is a difference in the surface, there is a difference in the dielectric property, there is a difference in the uh, frequently occurring changes. So those can be recorded with the help of microwave data. Generally, we use synthetic aperture radar, and which actually covers the remote sensing, uh, microwave remote sensing portion of the electromagnetic spectrum. So this is the general geometry of the acquisition or mode of acquisition of the microwave data, which is little bit different. Like we have a line of flight over here, as you are seeing, going from east to west, and there is a slanted acquisition. Like you don't have this broom push broom sort, but there is a beam sort, and which within this range only the information will be collected. So there is a azimuth flight direction. So along the azimuth, along the flight direction, there is an azimuth direction, and across that is a range. So we have a two kinds of resolution. One is the range and other is the azimuth. And depending upon our application, we can change it also. And there is a geometrical relationship with the earth surface feature, as you are seeing that there is a land parcel over here, and within the vertical portion of the nadir, the portion will be the near range and it will be a far range. So that will be collected with the far range and near range, which affects the image characteristic and the other. So we have a radar image like this, in which the depression angle along the azimuth direction and across the range direction will be there. So the entire range of electromagnetic spectrum, the microwave sensor senses from 1 millimeter to 1 meter, and we generally use the K band, KU band, X band, C band, S band, L band, and D band instead of 0.4 to 0.5 μm or nanometers. Generally, they are measured in the ultra high frequency, very high frequency, and high frequency. And because of their characteristic band portions in a particular wavelength, we use them accordingly. So water vapor absorption, oxygen absorption bands are within this particular range. But as we move from left to right, there is a change in the characteristic of the wavelengths, which provide us the clear information about the objects. So the relationship between the frequency and wavelength, as you have seen over here, is like this. So they are specifically given with their frequencies, and relationship between the wavelength and frequency is that as we move from lower wavelengths to higher wavelengths, the frequency gets decreased. Because of this formula, we can actually get the megahertz and gigahertz frequency also, and data can be ordered accordingly. So here, for example, we have a Ka band, so it will be ranging from 0.8 to 1.1 centimeter. It is in centimeters, and gigahertz will be 40 to 26.5. So if we have to see some event of any changes in topography and other things, then the data can be chosen accordingly, and that band can be actually C band, X band, S band. So they are actually specifically meant for the discrimination of the water vegetation, crop phenology, and other things. So now, after all this, we could understand that the microwave portion of remote sensing is rather useful during the flood or flood mapping than the optical data. And in this case, we use backscattered values rather than the digital numbers. So it observes the strength and the time delay of the return signal. So basically we have if the dB, that is decibel, is more, and it has detectability better, and there is a time delay ranging of the return signals, then the things will be more clear. It is as simple as we are moving with 100 km per hour speed, or we are moving with 30 km per hour speed. So the things will be more clearer and more detailed. Then we are moving faster, although we will be covering same area, but same scene will be there, but the detectability will be different. So if the time delay is more, the things will be better. And there are certain inconvenience also in the with this all data, that it has a complex interaction, like you cannot understand the data. The raw data is also it requires a lot of processing. Raw means to convert it into the process, georeferencing, other things. So many things are there which you may not understand also, and specific software is also required. Then speckle effects, it is difficult to means it is kind of sugar and or you can say salt and pepper like uh, information, very coarse. So it does not give a very good pictorial information. Then topographic effects sometimes have constraints like shadows and other things are there. Then effects of surface roughnesses. So all those things are generally being become inconvenient in the identification. So these are the one of the example of the microwave data and the clouded data taken in 1991 of August. So this was taken at 11:25 a.m. and this was taken at 9:40. So repeativity is there with the sensors, but the clarity is more in case of this R. This is the process of acquisition, means antenna transmits and it receives, and we have the pulses. So accordingly, the detectability means strength and the delay. We have two sorts of passive and active. When we have passive and when we have active, like passive remote sensing generally is defined as that when the sun is the source of the energy, and active means when the object itself emits the energy. So it is not only the enough thing, but where we use passive and where we use active. Like whenever there is a delay in the information, like when we want to record, or if the energy is recorded with a delayed time, then the passive mode is more applicable. And so in case of the microwave remote sensing, when the soil moisture content is to be studied or some hydrological aspect is to be studied, then then passive mode become or we should choose passive mode, radiometers and scatometers. While in case of very frequent changes like border information, cross border information is there, or any movement in the glaciers, है ना, or flooding, to we require a small spell of 7 days or 8 days, then active mode kind of things are important. So for hydrological aspect, for the different
Please
two
continue.
different modes and two different data sets. So for meteorological purposes, hydrological purposes, soil moisture content and all, we go for passive. So these are the certain things which are yeah, associated with the radar or the other data, which we should know actually before we use the data. So there are certain sensors with their specifications, and these are the different satellites. which have been mounted with the specific band characteristics and the sensors. In Indian context, we have reset 1 and reset 2 with C band and L band and C and X band, which I have already made you clear. So azimuth and range resolution, these are the two resolutions apart from your what you have heard and read: spectral, spatial, and temporal and radiometric. So these two have the ability of an imaging radar to separate two closely spaced scatterers in the direction parallel to the notion vector of the sensors. Like if you have two consecutive buildings, so two buildings, so how much capability it has to resolve those buildings apart. So that is its azimuth resolution along the direction of light. And range is means two closely spaced elements. So how best way it distinguishes, and there should not be any noise. So these two occur in case of the microwave remote sensing. So the interaction of the electromagnetic waves with the soil or the surfaces happens like this: if you have a dry soil, if you have a wet soil, and if you have a flooded soil. So in case of all the three characteristics of soil, the backscattered value, the strength of the backscatter value will change. Why it will change? Because of the water, as it acts as a film, and it provides the smoothness. So if the surface smoothness is there, or if surface ruggedness is there, so it will change the height of that particular surfaces, and then the backscattering value will change. And you are able to see over here that the here the incident energy is getting penetrated also and then being scattered. So this is a less backscattered intensity, and the dB value will be recorded as so the things will be will look different. While in case of wet soil, the large difference in electrical properties between water and air results in higher backscatter radar intensity, and the surface will appear brighter. Flooded is a specular reflected of the water surface, resulting in low backscatter intensity, and the flooded area appears dark on the sun. So wherever you see that the smoothness or the surface which is already having a flooded surface or the watered surface, the amount of this backscatter value will be very less recorded, and intensity is low, and therefore we have a surface in the form of darker areas. So as I showed you different images of reset and release 4, so where the water was appearing very dark along the river and the other places. In X band and in L band, so we have a different incidence wave. Like in case of the X band, it is the range of the wavelength is 3 centimeter, and in L band it is 25 centimeters. It is longer than the this X band. So the smooth surface will interact in a different manner. So reflected specular component will be relatively different, as the length of the scattered value will change. So it is a function of the surface roughness, is the wavelength dependent. So if the in X band, if the very rough surface is there, and if very high rough surface is there, or if it is a smooth surface, so backscattered diffuse component will differ accordingly, and the surfaces will have the smoothness and roughnesses in a different manner. So we have to choose very carefully that which particular surface is providing the information in a particular band. So length of the wave or the wavelength will will be recorded accordingly, and we can then have the information to be gathered. Similarly, over here we have a smooth surface and we have a rough surface. So backscatter value will be low, and in case of here the backscatter will be high. So scattering
Madam,
pattern will determine that what will
sorry,
be the
Madam, sorry for the interruption. Kindly conclude.
Okay. So in this way, we have this particular darkness and the brightness depending upon the strength. Data appears in this way, like we have a raw data, we have SLC, multi-look, and that can be processed further. And we use this because it is weather independent and flood area can be mapped nicely. So these are certain case studies which have been done. We can very well see that difference in the data sets and as per the dates. So we have actually used SCATSAT-1, which is a scatterometer data of microwave remote sensing. And when the Kerala flood in 2018 occurred, so it started from 8th of August to 21st of August, and there was a start period and there was an end period at 21st, and many of the areas were got affected. So we could actually first monitor from the 7th August to 21st August. All these states we had the analysis done for the rainfall in centimeters. So the peak was here at this particular time. And the situation in the land was like this, so which could also be seen from the imagery. So this was the portion which was very affected, and with the help of our analysis also it was found that the similar area got affected. Like we had a daily rainfall, so we geospatialized it और हमने इसको categorize किया. So we categorized them in centimeter from 0.14 to the 13.3 on the date 7th 8 2018. Then it was on 8th, the situation was this with the different categories. Then on 9th, so we started monitoring and analyzing the, the exact heavy rain which started from 7th to the 16th 11th 12th. And so you are able to see that the peak was different. The distribution of the rainfall was different with the dates. And when exactly it occurred on 16th, it was heavy over here, and then it preceded. So on 18th, so we could actually analyze and collected the data and then put over the word georeferenced all the gauges and then mapped it. And then the change detection, we applied the change detection over the images which we had taken of the same dates, like from 7th to 21st data where the data was downloaded, and we could see that the changes means the decreased part and the increased part. So increased one was like this, and the majority of increased part was here, which was having a very high damage in this particular portion. So this is one of the case study we could carry out, and which shows the similarity with the area which was over here also got affected. And the with this I conclude that we can actually use sentinel data whenever the mapping is required, and with data can be downloaded from here. from the flooding timeline and its peak, and then receding time and the receded. So all these four data can be downloaded from USGS site, which is given over here, and data look appear like this. And then it requires pre-processing, radiometric image calibration, despeckling, and terrain correction methods, and then sigma value with VV polarization we can do. Then the area can be processed like this. And after that, flood assessment tool and other things can be applied, and we can have the area which can be sliced like this. And then we can repeat the processes with the different bands also, and overlay it onto the Google image or wherever we require. And then we can see that the receding over the time, which area got affected and other things, so that can be mapped in QGIS. We can bring those information in QGIS, and further detailing can be done. So this is one of the small tutorial we have. And oh,
Okay, ma'am.
so sir,
Thank
here
you very
I
much.
finish.
Okay, okay. Okay, Dr. Jyoti Swarup, she has given very popular talk regarding flood, especially for the participant, those who are undergraduate or postgraduate. It is very, very helpful, especially the microwave data, how it could be used and what are the useful. And also, she has given a case study, and even all the steps she has narrated one by one, how to be flood could be assessed using microwave data. And lastly, she has used the settlement data also. Very nicely explained, especially for those who are the beginners, and for the mid-standard, especially those who are working, initiated or in middle stage. Is very, very useful and nicely she has elaborated. So I should put my thanks to her for the benefit of the students. Now, madam,
Thank you, sir.
very small questions are there.
Yes, sir.
If you are ready, then I can ask you.
Yes, sir.
One question asked. Question is very simple, but it's you have to answer. Dr. Parag Dalal. Suppose two people does remote sensing on same area or nearby area. They are getting different results. Then what to do?
See, if they are getting different results with the same area they are having, then the things can be actually done with the help of ground truthing. So if um, any change in resolution, or if any change in scale that has occurred, so that can be actually verified with the ground details also, by having some points onto the imagery, and then that can be um, verified in the field, and then can be corrected and rectified later.
Okay, nice answer, ma'am. Second is
Sometimes
also,
what happens, there is an earthquake which occurred. So on topo sheet we see the different location, latitude and longitude, and after earthquakes the whole village being shifted to other places, so that provide us the different latitude and longitude. So although we see the same village name, same area onto the imagery and other classical maps, but which requires further updating of the or editing of the lat long and the other locations to be um, incorporated in the maps.
yes, ma'am. Then second question is that how to use relief maps in remote sensing and GIS.
Relief maps.
Hmm.
Relief if I am taking it as elevation, like relief
Yes.
maps, है ना? So
Yes.
we can take the point heights, or we can take the heights of the known areas, and can incorporate in in the images for generating the stereo data, for generating the DEM and three-dimensional viewing and other things. So that helps us out in accurate placing of the point heights onto the imagery.
Yes, ma'am. It is in the same fashion, like how to prepare DM, digital elevation model. And first you have to learn DM, how to generate, then automatically it will come the relief map also, how to be drafting or preparing. And another one question is there. Why are there problems in creating a DM from an SAR image?
Okay. So DEM requires actually Z value also. Like if you have a contour, simple, if I give you an example, like if we have a contours, we digitize it, we give a value of 280 to 300, 320, 300, and likewise we have a line contour digitized, and we provide the value, so we can create a DM out of that. Okay, very simple way, and that will provide us the elevation of each of the pixel value. The second part is we can use microwave remote sensing, which provide us directly the height values by targeting the objects at a particular point with a time difference. So phase difference is there, and the point which is targeted gives us the amplitude, and with that particular difference we process the data and we get the DEM. So SRTM is one of the DEM which is processed throughout the world, and at 10 meter and 30 meter it is available.
Okay, thank you, ma'am. Once again, now the second speaker, and second speaker is myself. I have to speak. That is also related to the flood on flood DRR.
So, okay,
And-
sir, I will leave, and thank
Okay,
you so
ma'am.
much. Okay, sir.
Now I request Deepali to go ahead with this.
Sure, sir. Thank you, sir. Now I would like to call upon the second speaker of today, Dr. A.L. Haldar. Before calling upon him, I would like to give a brief introduction about sir. He has obtained post-graduation degree in exploration geophysics from IIT Kharagpur in 1985 and received PhD degree from Vikram University, Ujjain in the year 2003, which he had pursued during the job. After passing out IIT Kharagpur, he served Danish International Development Project Government of Odisha, Bhubaneswar as geophysicist, and he performed massive groundwater exploration of the fresh water in the coastal belt of Odisha. Thereafter, he joined Remote Sensing Application Center, UP Lucknow, as Scientist SC and elevated to Scientist SG. Worked on the geophysical exploration for groundwater on hard rock area of Bundelkhand as well as alluvial area of entire UP, remote sensing GIS and DGPS, LiDAR and bathymetry. Lots of work he has carried out on industrial resource mapping for the state of Uttar Pradesh, and he has completed more than 38 projects sponsored by internationally, nationally, state of UP and other state. And he was also appointed as the director of the Remote Sensing Application Center for a duration of 2 years and got superannuated in March 2020. Presently, he is working as consultant flood monitoring cell at NIDM, and to the credit, he had 67 technical paper in international national journal and symposium. He has also visited several foreign countries, France, Italy, and Switzerland for technical program. With this, I now invite Dr. Haldar to please take over the stage. Over to you, sir.
Okay, thank you for nice introduction.
Sir.
Now I'll share my PPT. Deepali, is it visible?
Yes, sir, it's
Hello.
visible. Please turn on to slideshow.
Yes, now what I feel it may come.
Yes, sir. Please go ahead.
Now, good afternoon, gentlemen, and Professor Surya Prakash, Head of Division. He is joined. All the time, generally, he is to be busy for different all the types of program, but still he has given time to join. And Professor Barma, that he was during my PhD duration, he was also professor there. So I'm quite fortunate that we are getting him, and today he's in the dais also. So good afternoon, everybody. Now, before my speak, Dr. Jyoti Swarup, she talked about a lot regarding the how to use remote sensing data, even for microwave data, which are very, very useful, especially during the cloudy season. And he talked about the steps and everything. Now I'll go in some other aspects of flood, that is the ecosystem-based flood disaster risk reduction and resilience. Yes, what I hope the slide is changed, Dipali.
Yes, sir.
So yeah, now this is the all over India scenario. That is a brief gist is given here. You see, we have taken a quite more than 15 years, or say 1953 to 2019. In this duration, that is almost say 70 years or 72 years, we have seen, if you see the flood status of India as per area, the flooded affected area in every year, it was 7.14 million hectares. That is up to 2019. During that period, you might be knowing that how much flash flood is affected in India, and due to the different causes, and especially in Mumbai, Kerala, then Delhi also, even West Bengal, Uttarakhand, which is very, very concerned for the flash flood, it is happening. But of course, nowadays, it has taken for the last 70 years. But if you take the average for this recent, say last 15 years, you will find it is quite more than 3-4 times, at least more than thrice. And the crop area affected during that period, it is 4.02 million hectare year, almost 2 to 3%. But nowadays it is, you know that in India, out of 27 state and 8 union territory UTs, out of that, more than 18 state and 2-3 union territories, they are getting affected each year. This year it was also 18 states and 2-3 UTs. Then cattle lives, you see, average is that human lives. Earlier it was, during the 70 years, it was 1674, but it is increasing. If you reduce the period means year. Population affected, it is also similarly, it is increasing. Of course, nowadays flood is moderating by different state and by the Central Water Commission. Of course, it is, especially in the Gangetic Plain and the Northeast India, they are the very, very severe affected, and in the eastern coast. And sometimes in the Gujarat coast and in the west coast, the Konkan region, it is also having rainfall. This is the, the flood prone area. Mostly 3 types of floods are there. One is riverine flood, that is earlier or even nowadays it is there. It happens especially in Gangetic region and Brahmaputra region also. And each year it used to come as usual, but nowadays quantum as well as frequency is increased. This year, several attacks were there, especially in the eastern part of India, in West Bengal, several times since the month of May. It has started when the cyclone Yas has struck. During that time, till now, even the Kharif crop harvested. This year, at the time of harvesting also, rainfall was so much. What I mean to say that in the riverine plain, that frequency and quantum is increased year by year. And the flash flood, you do not know when and where it is happening, but it is quite common in Kerala and Uttarakhand. Since 2018 onwards, it is coming. Now the urban floods are also common in, say, Mumbai, Chennai, even storm flood is there in Kolkata. during Kolkata is basically there happen during the summer season, that is called Kal Baisakhi. If once Kal Baisakhi, it happens generally 3-4 days, or say 3 days at least at a consistent, that if the temperature is rising, then on the 4th day or 5th day definitely some rainfall is there. That is in Bengal, that called in local language Kal Baisakhi. That Kal Baisakhi gives enormous rainfall. Prior to that, lot of wind, that cyclone type effect, and this is very common. And this year means 2021, within this monsoonal year, it was plenty was there. Even also we are facing the same fashion in central India. Often and then rainfalls are there. And also, the scenario of coastal flood. It happens, you do not know what is the boundary between the sea and cloud. It was so dark. If you see that coastal flood is quite common, and it is happening each year. Now, if you see the graph, that what is happening in flash flood and what is happening in riverine flood. During the flash flood, the base flow, before the base flow, the time duration is less, and suddenly the peak will be increased, say within few hours. So within maybe it may be 2-3 hours, or maybe it's 10 hours. But for that is for the flash flood. But for other flood, riverine flood, generally it will not rise in that much way. But if at all it will rise, but it will not fall suddenly, unlike flash flood. So here in this graph, right side, if you can see, you can find that this is the peak, how nicely it is visualized. And here that warning level, danger level in the flood, in that within the water level respect, it has been given. Now in the bottom, that is a riverine flood. And here it is in scenario of Uttarakhand in flash flood. Of course, certain definition has, and Kerala flood also, Dr. Swaroop, Professor Swaroop H.C. talked, but I'll not go into details for that. And that flood is basically a natural, a high flow of water which takes the natural channel provided for the runoff. And flood is the general such area where normally it was dry, and suddenly, or means within the time limit, it has been dry. And before that, it was dry and it was suddenly submerged. So that is the basic definition of flood. And I should not stop until saying that this last year, 2021, in February, that is the peak season or the season of winter, and that is the peak season in Uttarakhand. That in the area Chamoli disaster, suddenly it happened. The basic things that some glacier or nearby some lake, it has been out busted. And in the downside, that was in this 2 power plants were there. There are 2 big tunnels that has been totally submerged with the full of debris which has come out from the upper side, and lot of bodies, do not know. So far in government record, 83 bodies were recovered, and some 36 human bodies parts were also recovered, and more than 200 people are missing. Nobody knows what is the exact figure of casualty still then. That in that charter, International Charter for Space and Major Disaster, it is published and confirmed that a large rock and avalanche as the cause of the disaster. It means that where the ice mass is there, suddenly it has been slips down and it has been fallen. Why? Now that is due to the slipping of the glacier, and it is broken from there, and it has fallen down through the river, and heavy debris with water and other debris were there, and it is came down more than 2 kilometers. It is fallen, and it has happened the disaster in Chamoli district and nearby area. Similarly, that cyclone Yas, it has made severe destruction in Odisha coast, and landfall was in Odisha near Bhadrak, and but it was casualties were there in West Bengal. But of course, forecasting were there, early warning were there, very less casualty taken place. But flood, especially near the seashore, it was tremendous and submerged the tourist spot and other area. Bengal, especially in that area, in Digha area, it is very popular for tourists, and that was a peak season. And at that time, that so much big waves were there, generated more than a tree of coconut. It means more than say 15 meter. That much big waves were coming during the landfall of Yas. So this is the different characteristics of flood. I'm not going to that, keeping in time constraint. So I should tell also what are the what are the basic causes of flood. You know, the high intensity of rainfall. That is the also present causes for the flash flood also. And meandering course of river. If certain rivers are there in alluvial plain, in more meandering, that will give the flood also. And obstruction of floodplain. You know, nowadays, due to the urbanization and due to the need of people, that floodplains are being used and it is being constructed for various purposes for their own. Of course, government is trying, court is trying to remove those things, but still it is not in that earlier condition. So that is the main drawback for the flood in different areas, not only urban, but in rural areas also. Because that is the floodplain, that is the area which can absorb certain amount of water before inundation in nearby area. But that is being concretized and no drains are spare and it is blocked. So this is immediately, whenever rainfall is there, and a certain petty amount, good amount, then suddenly flood is coming in most of the area, not only urban, but in semi-urban and rural areas also. And river, channels, valleys, both are obstructed. Suppose in that area, that is the Uttarakhand, what happens? General landslides used to take place and the channels, they used to get obstructed, they used to get blocked, and this is the main cause for the flood. In the riverine area, also same thing, it is blocking. Of course, government is taking care, but not outmost. If it had been taken care, then it would be there. Another cause is there, that desilting in the river and channel. It is fully, even the canals are fully silted. And it is, if you moderate the siltation, and nowadays very good technologies are there. By using bathymetry, you can see where the most major amount of silt is there, and if you can desilt it, then definitely that you can moderate the flood. Nowadays in certain state, they are doing the moderation or the desiltation and using the bathymetry technology and the appropriate mechanism to remove the silt. And of course, another important cause maybe that is the climate change. You know, due to the climate change, day by day, temperature, global warming, or the temperature, average temperature is increasing. That it is predicted by 2021 that whatever normal temperature is there, and it may increase 2 degrees centigrade or more, then it will give a serious cause for the human, cattle, and public life, not only India, in globally. So these are the natural causes, and some of the, apart from that, some anthropogenic causes are there. So you can see that building activity and eventual urbanization, and also agricultural practices. These agricultural practices, this is also creating some obstruction due to the field burn and other thing. So generally, if some mischievous farmer is there, they are blocking the drain also. That is also one of the causes. One important cause is the deforestation. Generally, deforestation are there. Everywhere trees are cutting, very less trees are there. That is one of the cause for the flood. And channel manipulation through diversion of channel course. That is also another cause. So we should take precautionary measure to remain safe from flood as we need when and how deal with them. Lives should be saved by having more warning of floods for places in threat. Which are the places in threat, especially in northeastern, that Assam, and nowadays it is there in Uttarakhand as well as Kerala. If you alarm, the early warning will be there, then it will give a lot of relief. And also, so these are the area India has already mapped. NRSC, the Department of Space, they have mapped what are the flood-prone area almost in each state. Nowadays, they are proposite-wise or district-wise creating a lot of other maps for the flood, for the relief of, to giving the relief from flood. And but however, they have created the flood-prone area. In those areas, the anti-flood protection is required. And of course, in certain states, see Bengal, where the cyclone is quite common, and Odisha, they have created, and also some other state which are the flood proof. They have determined they're shifting at the time or whenever warning is given for at the time of flood. They are shifting the people. So this is the one example of Eastern UP, that is in Gorakhpur area. During 99, that was a tremendous flood in Gorakhpur and Maharajganj districts. That it has started, say, 3rd August and continued till the end of August, say 29th. And almost in those two districts, almost 60% area were submerged for a quite long period. Now, if you see the green color, that was the water remain from 3rd August to the rest, that is the 29th August. So now you can realize what are the casualty and how many, what are the status of the crop damage you see. This is radar set data of Rapti and Ghagra river. You see dark color from where you can visualize what is the quantum of flood during that period. Now, for reducing flood, we have to manage, and Central Water Commission is obviously they are managing. Initial risk will be more, but in federal, state, and local level, you have to create the zoning, means the flood-prone zoning you have to create, building code, risk communication, what are the risk, and that you have to communicate, and an evacuation plan. Definitely, government is taking place, NGOs are also coming for evacuation, and for natural storage, that is the levees and big tanks, they are repaired. Of course, the flood walls, especially the big rivers are there, embankments are there. Apart from the embankment, the flood walls they are creating. Even in nowadays, that metros, the flood walls are already there. So rather than we have to create, we have to demolish so that flood water can recede. Or else in Chennai, you have seen that flood, why it was remain more than 15 days, 20 days, due to the blocking of surrounding, and flood water could not pass in. Flood proofing is there, repair. These are the individual house owner. They have to manage flood proofing. Even for the house surrounded, they have to create a bonding, and insurance is repaired. So to give the relief, you need the structural measures. You know the dams. This is a quite old concept, obviously, but it has given obviously a lot of relief in India. Big dams are there. You see Ukai Dam in Gujarat, in Damodar Valley, in Damodar River, a lot of dams have been created. Maithon, Panchet, and nearby Bokaro, all the dams are there. They are moderating. In the big dam, during the heavy rainy season, they are stopping. But of course, if the limit is over and rainfall is continuing, so they have to release, or else they are absorbing in the upper catchment if rainfall is more. So it means the reservoir and dams, and India has constructed more than 5,000 dams, and it is giving a good, that is a flood cushion during the main season of the flood. And the inter-basin transfer, that is the recent thinking, and obviously Ken-Betwa linking from Government of India. Prime Minister has given hints Now, if you take place that if it is success, then of course it may be time taken because it is a huge project, lot of areas there, lot of other activities are there, and it may take time. But of course, if it will be the definitely viable, so that in India generally sometimes somewhere it is drought and sometimes in the same year it is flood, so it could be managed. So what happened in Rajasthan earlier, but nowadays it is managing due to the Indira Gandhi canal is there. It is so like this in India, big rivers or certain rivers, if it is interlinked, then it will be managed nicely, and India's economy will be also colorful and it will be changed a lot. Next important aspect is embankment. The embankment in the river, big rivers are there where I was telling that these silts are deposited. And due to the deposition of the silt, during the flood season, the river is shifting. It means some other area, the cutting is there in land and it is shifting. You might have heard in the Kosi River, that was originally where it was, they have shifted. You will not believe it is more than 100 kilometers is being shifted in Kosi River. But why? Not due to the silt deposition, first thing. Second thing, rainfall heavy is there, and the nearby area where cutting is there, so it is there. So now it needs the embankments. Embankments are there, now that has to be strengthened. If required, proper monitoring should be there, and during the monitoring period, appropriate care should be taken. In certain state, it is modernized. Obviously, in certain state, it is there in Bengal, Odisha, and especially in UP. They are moderating the flood. Last few years, they are moderated by the embankment vigilance and the removing of silt. They are managed. Similarly, other aspect is the anti-erosion work, channel or drainage improvement. In India, more than 39,000 drainage channels are constructed for giving the relief of channel. And also it requires the structural measure for river diversion. For the non-structural measure, this is the ultimate need, and that is, and obviously last quite more than 3 decades or 4 decades, Central Water Commission is doing. Even nowadays, this early warning system in NGRI, National Geophysical Research Institute, through the environmental seismic, they are controlling. It means that whenever flood is there, they are monitoring through their seismograph. And during that period, they are monitoring a lot of, forecast station and alarming station, monitoring station, they have placed and they are observing, and also they are creating the flood forecasting. Flood zoning, what I was telling, it is required, and they are taking, each state government and central government, they are doing, flood proofing is required, similarly for flood insurance is required. So for flood forecasting, that river water level or the inflow in the river in advance has to be alert during the concerned period. And river water level forecast for town and habitation is required. Reservoir inflow, it will forecast the reservoir operation. You know, there are 2 forecasts. One is inflow and other is river water level forecast. River water level forecast and inflow forecast. The river water level forecast, it will give to the habitation nearby the river or adjacent. But the inflow forecast, it will give the reservoir operation obviously, but it will not give the habitation. But for the river water level forecast, that will give the forecast for the town and habitation area. And other things are there. There is the inundation forecast, are likely, which are areas are to be inundated. They are doing for that. Afterwards, that is doing, obviously, Central Water Commission is recently, they are going to start one pilot project for that. GLOF, Glacial Lake Outburst Flood, that is there. And for that, lot of happenings are taking place, starting from flood, landslide, and casualty. So these are the institutions who are involved for the flood, early warning and flood warning purposes. Say IMD, NRSC Hyderabad, Central Water Commission, state government, they are doing, Ministry of Home Affairs, etc. So this is the flow that for the flood forecasting and disaster management. So during the flood, the Central Water Commission, they have started that whenever warning level, they are giving the warning when some certain limits are there, when it is going above normal, they'll put the yellow observation. Similarly for danger color, danger line, when it is crossed, they'll put the orange. And when it is severe, it means what overtaken the boundary of limit, then they'll show the red color, that is the high flood level. So these are the different station inflow forecasting and level forecasting. You see this blue color, if you see the blue color, especially it is predominant in the peninsula in the southern part of the India, that is the inflow. And level flush, that is the river and adjoining area, that is the green color. These are the approximate are their level, water level forecasting and forecasting, that is there say 198, and inflow it is 130. More than 1700 stations are there in India. Now you see the flash flood, Madam shown certain case study in Kerala. So similarly for Chennai flood, that measure is there. So how you will protect? Now these are the certain equipment, certain protection measure. The red color you are seeing, that flood water could be diverted in small scale, obviously, not in large scale. And the environment could be benefited by flooding. So the flooding, it will be benefited by the fisheries, wetland and irrigation, obviously. But of course, too much flood, it cannot give the benefit. It will destroy all, so starting from fish to irrigation, and wetland would be destroyed also. And floodplains, which is the highest development potential, it comes to economic development. The floodplain has to be safe and has to be restored as it is under condition. Then and that you can go for the normal way flood management. How the nature can help to reduce flood. First thing, the floodplain has to remove, and the restoring of reefs, marshes and dunes that can protect the coastal communities. Similarly, for the river, where the heavy silt is there, that has to moderate. But of course, if you moderate, if you remove the silt, next year it will be deposited in the same places, but that year it will moderate the flood. And of course, some silt, they are useful for the cultivation, but it is a problem for where to keep all the silts. Certain silts, they are productive for obviously agriculture, but all the silts cannot be absorbed. So that is the benefit, and it is a cost effective. So certain demerits are there, but it can moderate the flood. The natural levees, that is required. You see, the levees are there, and if the side wall, in the natural levee, the side wall, sometimes it is been washed away out, and if you properly construct it and properly again reconstruct it, then it could manage. So in the flood control, the flood wall, levees, these are the required. So you see here, this is the levees are properly managed, and flood control structures are properly managed. So the water is during the peak season, it can be moderated, it can be nicely managed, and so that inundation will not be that much. So this is the nature-based flood system management, what I was telling. And ecosystematically routine of flood water. So that bathymetry technology is very useful. In some state they are doing, and of course the big reservoirs, they are full of this silt. You see this NHPC project is there in Hindalco and other area, they full of ash. Now, so how the dam will be used for the hydroelectric construction, for hydroelectric purposes? If those will be removed, Initially, you have to check how much silt is there. After that, you have to remove. Then and that flood moderation and other purposes there. So bathymetry technique can help a lot. So you see, this is the bathymetry technology. This dark blue color, where the concentration or the quantum of silt is more. So the principle is the sonar. It means that below water, that one sensor will be given, that is called hydrophone, and that will map the deep of the water level or deep or the level of the silt, and it can continue all around the dam, say, and you can figure or you can monitor or you can prepare the contour, and you can see how much silt is there and how to be removed. You can plan it also. Ecosystem-based adaptation to increase the flood resilience. It describes the use of ecosystem-based as a tool for strengthening flood resilience, approach that takes into consideration for vulnerable groups whose livelihoods directly depend on natural resources, especially in the coastal belt. You might be knowing that if the global temperature will be increasing, say 1 degree or say 2 degree, then 1/3 area where a lot of people are there, they're supplying food for the nearby area or to the India, so they'll be submerged. So they will be totally lost first thing, but in India, it will be losing the food production at least 1/3. So we have to think seriously for that, how to be mitigate. So this disaster, this National Institute of Disaster Management, they are trying their effort, starting from university, colleges, different stakeholder and government departments, for the preparedness, for the for mitigation, not only flood, for fire, seismic, and chemical. All the disasters are there. More than 14 types of disasters are there. Not only natural disaster, but also say this man-made disaster, chemical disaster, biological disaster, what is going on in this pandemic. You cannot stop, but you can moderate the work. So these are the ecosystem based, which can increase the resilience. Developing countries are especially vulnerable to floods due to their limited capacity to prevent and absorb disaster effects. Within developing countries, the poorest people are often most vulnerable because they are not that much obstructed by the flood. They are there in the nearby shore area or other area, which are immediately, whenever excess rainfall is there, they are getting affected. So they are the vulnerable groups. So we have to think for proper rehabilitation, for their economic growth in the different level. The socio-cultural circumstances lead to increased deaths among the women during floods and higher poverty rates, and due to more unemployment. So a lot of demerits are there, but you have to be environmental based, ecosystem based. You have to make the resilience in that nearby area so that properly. For that, you require the flood-prone area to be removed from the using the urbanization or other concern. The ecosystem-based adaptation, a few words to be maintained for disaster risk reduction resilience. The floodplains, what I am taking several times, natural levees has to be given proper importance. River beds to be free from sand, silt. Coastal shore areas to be maintained clean, so that whenever coastal belt area water is there, they can nicely go and to the sea. Hilly areas are to be free from heavy construction, because in the hilly area, often and then the landslides are taking place and it is choking the drainage. So that's all from my side. Thank you very much, participants. If at all, let me see if anything is there, question from your side. Deepali, could you hear me? Deepali?
Yes, sir. Yes, sir.
Now please check if at all any question is there.
Is none of the questions are there right now.
Okay, please.
You can check again if somebody posts. So you may check in your host account also. Maybe
Yes, some
somebody
problem
has.
is there. That's why I'm asking you. No question is there?
No question is there, sir, in the
Okay,
chat
no
box.
problem. Now we can go ahead. You can call Professor Surya Prakash because he has some problem arised. Professor Surya Prakash, that he should either he has joined or not. Please see.
Sir is already there, I think, sir.
Okay. Now you please request him, sir. Please be there so that I can.
Now I would like to call upon Professor Surya
Yes,
Prakash, Head
please call him.
JMRT,
Yes.
NIDM, to propose the valedictory session and concluding remarks for this training session. Over to you, sir.
Thank you, Dipali ji. Am I audible?
Yes, sir. You are audible.
Okay. First of all, let me congratulate Dr. Amritlal Haldar, the coordinator for this program, for the successful conduct of these 3 days program jointly with the Vikram University Ujjain. And we are also thankful to the Vice Chancellor Ujjain, Vikram University Ujjain, for collaborating with us in this particular program. Disaster risk reduction is nowadays very much focused with the invasion of COVID-19 pandemics since December 2019. It has been well realized that such kind of major disasters affecting diverse areas cannot be easily controlled without the implementation of the provisions under the Disaster Management Act 2005. Both the departments of health as well as the disaster management, they joined hands together to develop guidelines, procedures, and also to strengthen infrastructure to deal with such kind of major disaster that has affected vast population of the country. Not only within the country, this disease had actually spread out across the globe in several countries and affected billions of people. Even the developed nations, they had to face the adversities of this kind of pandemics, which was not felt earlier. So now the principles of disaster management, in which we are always talking about collaboration, control and command systems or connectivity with others, has actually served the basis for reducing the consequences or containing and controlling the consequences of such kind of COVID-19 like pandemics. Besides the COVID-19 pandemics, there are many other disasters which have struck us during the last 2 years, including the cyclones like Amphan, Nisarg, Yas, Taute, and also several floods and landslides which had occurred within the country. So this actually required a multi-hazard perspective as envisaged in our National Policy on Disaster Management, which was released on 22nd October 2009, and also looked upon as one of the major factors in the National Disaster Management Plan, which was revised after 2016 in 2019. In 2019, it was well realized that the 4 priority actions which have been defined under the Sendai framework for disaster risk reduction and resilience, including the understanding disaster risks, strengthening the governance for disaster risk reduction, investing in disaster risk reduction and resilience, as well as build back better and lessons learned from the recent and the past disasters, and including those lessons in our recovery and rehabilitation programs. All these were actually practiced will included into the national plan as well as in the state level disaster management plans by some of the states. Besides that, we had 7 targets in the Sendai framework, which included the reduction in the number of the casualties, which has also been looked into. Then second is the number of affected population, and the third was reduction in economic damages and losses to our properties and assets. And also the focus was given particularly reduction to the damage and loss to health and educational buildings. Universities being the academic centers of the country, they have to actually develop their own disaster management plan, and also they have to actually take the way forward for the future generations, as NV says in the National Policy on Disaster Management, that we have to build a culture of risk assessment, prevention, mitigation, and preparedness, rather than ad hoc piecemeal response mechanisms. So therefore, universities have to take up the curriculums on disaster management, start with the courses on disaster management, and also these kind of disaster management education and trainings have to be included in all subjects, all disciplines, all sectors, and all streams. This was well realized way back, I remember, in 2005, when the second Administrative Reforms Commission meetings were held, and they pointed out that disaster management should be included into the education sector, right from the primary level to secondary and higher levels or tertiary levels. And this was taken up by the University Grants Commission as well as AICT, and they constituted committees way back in 2009 and 10. It's almost more than a decade when these curriculums were developed, and the notifications were made to all the universities, be it the technical universities or organizations, or the general education, including both all science, arts, and commerce. They were expected to actually teach a subject on disaster management as per the curriculum which was developed by the UGC and AICT separately, and later on it was introduced in many of the colleges, universities, and technical organizations. So later on, we have also found that many of the universities took up the responsibilities to start PG courses in disaster management. Now we have MBA in disaster management, we have MA in disaster management, we have MSc in disaster management, and several other such programs. And the new education policy which has come up in 2020, they actually started with the new courses also, and that provided new opportunities as well for the certificate, diploma, and PG courses in disaster management. So disaster management, the universities have taken good initiatives, and on the other side, the health infrastructure, the health departments have also realized the importance of the disaster situations, and they have also prepared themselves against these kind of situations. If you see the first and the second wave, we had to actually gather a lot of resources for our health sector, but in the third wave, these resources are good enough to meet the challenges and the needs of the current COVID situation. So this is what actually is required. And for pooling these resources, NIDM actually developed a portal called India Disaster Resources Network. You can see it, idrn.gov.in, where all such resources which are required for disaster risk reduction and resilience as well as response, they are available on site from all the districts, states, and UTs of the country. Collaboration is very much required, and it has again been emphasized in the Sendai framework under the targets. And one more fact I would like to highlight here in this valedictory session is that we have to have actually a good, reliable early warning system, which includes not only the alerts about the potential or emerging and likely disasters, but also provides the guidance to be for the actions to be taken or not to be taken, do's and don'ts for the concerned stakeholders, so that adequate timely actions take place at each place to prevent the adverse consequences of those hazardous events. We should not let hazards turn into disasters. Hazards may be inevitable, but disasters are preventable. And that's where the human role comes. And education and training provides us that power of knowledge to deal with such disasters. किसी ने कहा है ना, शायर ने कहा है कि जगाना आता है उसे कई तरीकों से, दरों पर दस्तक देने खुदा नहीं आता, पड़े रहो सहमे हुए यूं ही, अगर हवाओं के पर बांधना नहीं आता. So you have to learn to tame disasters rather than getting tamed by them. So these opportunities we should actually utilize in terms of the lessons learned, what the actions taken, what went wrong, what went right, what are the bad practices, what are those good practices which need to be retained, and bad practices need to be eliminated or alleviated from our society. So I would urge participants to kindly bring into action all those inputs which you have acquired through this 3 days online training program, and also share it with others, disseminate to others, so that it has the last mile connectivity. In this Sunday framework, we have been talking about all inclusive approach and also ecosystem based disaster risk reduction and resilience. All the elements within a given environment, they are all mostly interlinked, interrelated, or interdependent. So therefore, it's not just the human elements which we need to care, or the resources of human interest, but also all the elements within our environment, or all kind of entities which have to exist together. So let's work in an environment friendly lifestyles. As we said in the COVID-19, COVID appropriate behavior can help us a lot in blocking the chain and reducing the risk and enhancing our resilience against pandemics. So I would urge that all those students, faculty, and other participants who attended this program should not just go away with the participation and certification. They should also serve as ambassadors of DRR&R and disseminate with others, and also bring it the important actions into their practices for disaster risk reduction and resilience. So all these efforts and resources have been actually spared and attributed just to see that our future generations are in a more safer environment, adapted to the changing climatic conditions, go for sustainable developmental goals, and also make themselves resilient against the potential existing or emerging disaster risks and threats. So with these words, I wish all the best. किसी ने शायर ने कहा है कि मंजिलें उन्हीं को मिलती हैं जो सफर अख्तियार करते हैं, ऐसे मुसाफिरों को तैयार हो, रास्ते भी इंतजार करते हैं. So we have started our journey towards disaster risk reduction and resilience, and we have to continue this, as Vivekanand ji said, that stop not till the goal is achieved. So we have to sustain this process. One-time endeavors may not be good enough. So we will continue to update ourselves. This is a dynamic process and will continue to change. And therefore, we must update ourselves, revise our plans, and act according to the existing situations rather than being dormant and just going away with episodic events. So that's my message. And these are not very easy situations, as some poet has said, woods are thick, dark, and deep before I sleep. So that's a way that disasters show. So we must not stop with the attendance or participation in the programs, but continue our action and sustain these efforts to achieve resilience and ensure safety within our country as per our national policy for zero casualty, disaster-free, and resilient nation. With these words, I thank you for this opportunity, and back to you, Ms. Dipali.
Thank you so much, sir, for sharing your words of wisdom, and thank you so much for bringing your expertise and experience around the table. And it's true that disaster management is a collective and coordinated effort, and everyone must take an active part in disaster management to reduce the risk of human life. And it is very much necessary to learn to mitigate the disasters and spread the building back better approach to post-disaster recovery that reduces vulnerability to the future disasters. So
Yes.
thank you so much once again, sir. Now I hand over the stage back to Dr. A.L. Haldar to continue with the program.
Okay,
Over to you.
Dipali, thank you. Thank you very much. There was some technical glitches. That's why it was inconvenient. Now it's okay. Now you have learned a lot of things from our dynamic man, Professor Surya Prakash. He's all the times he's busy. He's having more than 12 ministry. So I should tell these things before, but due to inconvenience, I could not. He's having more than 12 ministry to maintain all the things related to disaster and documentation and other things. And he is faculty in charge of 6 specialized center, starting from early warning, communication, hill area development, coastal DRR, flood, industrial DRR, cyber DRR, etc. And he is team leader of World Center Excellence in Landslides for reduction. And he is also supervisor and in charge of flood monitoring and emergency responses. So generally he talks and very thought-provoking things seems to deliver for the beneficiaries, for the stakeholder, user department, students, and he's always there. Now, on behalf of Vice Chancellor, Professor E.K. Pandey, our Professor Pramod Kumar, he was also presently, he has relieved from the Vice Chancellor in Barkatullah University. He is with, he is us in the stage, and he will give the blessings, and he will talk about the special address for our audience in this forum. So already you are aware of his biodata. So presently he is director in IQAC at Ujjain, and faculty member is there. And recently, I should not say formally, recently he is released from Vice Chancellor of Barkatullah University, Bhopal. That is a prestigious university. And he was also in government of MP. He was Director General of MP CST and scientific advisor to MP. And he was also director in MP Remote Sensing Application Center. And he is, to his credit, he's having a lot of presidency, vice presidency in this Indian society and geoinformatics. And of course, his gold medalist, he's having very good quality in his endeavor. So with this, I'll request Professor Barma to say something or a brief details or something about that in this special discussion. Professor Barma, please.
Namaskar. Am I audible?
Yes, sir. Yes, sir.
Okay. So, Namaskar, Haldar Sahab and Surya Prakash ji. While listening to Dr. Surya Prakash ji, and a wonderful summary, he summed up everything. And then he also told about his assignments, responsibility, marvelous. So, people like him are doing a great job to the country. And because this is the concluding session, so I don't speak much about it. But on behalf of Vice Chancellor, Vikram University Ujjain, and in general, all participants from the Vikram University Ujjain, we are very much thankful to NIDM to selecting Vikram University as one of the hosts to have this 3-day training session and to inviting the very good, very reputed speakers on different various topics. Certainly, this disaster risk management and disaster management is not only a management problem, because it has a science also, it has a arts also, it has a community system development also, communication also, so many things, a combination together. So this is a topic of common interest actually. So that's why I think the Haldar arranged this speaker from the remote sensing field, also from the some radar data also management, also general people also. In future, I would like to say that we should continue with this in a different university of Madhya Pradesh also, and for this place also. And I would request the authority at NIDM that we would like to interact with NIDM in a more proactive way by sending our students for this internship, or maybe having some joint seminars on so many things. You know, Vikram University is also a very old university. We are working since 1957, and presently also we are a grade university by the NAC, graded by NAC. So I think we have the capacity of listening, learning, delivering, and doing so many things. But still, you know, networking is the best thing in modern age. So we cannot compete with the specialization at NIDM, but we can have experience, we can have learning, we can have a cooperation from the NIDM to our students, even for the young faculty and all that. So for this purpose, I would request the NIDM authority through this Dr. Haldar that we will put a request to NIDM that kindly, either in the form of MOU or in the form of a case-to-case basis, I don't know which form you will come forward, but we would like to have a permanent relationship with NIDM for different kind of academic activities, even maybe practical activities, you know, because you know, Ujjain is a very place where every 12 years we have a singers Kumbh Mela, what you call. So we get more than crores of people here for a month or so. So how intelligently people manage here without any disaster. So that is also a learning experience. That is of course a human made everything. So it can lead to anything. We had some few years ago, we had a small disaster in Mahakal template because due to the stampede, due to the mud and all that. But we have learned from this that now how to manage the people, how to manage the crowd, how to do it. But this is one thing. Second thing is that we have here in Malwa region, because Bikram is located in the Malwa region, western part of Madhya Pradesh. So we have a good network of rivers here, you know, and many rivers are being now talked about to linking to this river also. We are having water pumping from Ramada river and putting to our own Shipra river, Gambhir river, and other river. The Chambal is the other big river in nearby area. So we have a lot of rivers here together. Can we develop a proper action plan for all these rivers with the help of an IDM? Because not only for agriculture, for drinking, for many other things, you know, these things are needed. So I think that we have to go for an integrated plan, not only academic, but also for the community, for the practical purpose. And so we have enough number of manpower. I must say that they are quite good enough people. We have NSS unit, we have NCC unit, we are our almost 28, 29 departments here, almost all sort of faculty, right from science, arts, commerce, IT, engineering, except medicine, we have everything. All medicine, we had medicine also, but now medicine has gone to a different university decided by the government of Madhya Pradesh. But we have all the faculty, all the medicine, good number of teachers, good number of students, good number of research scholars. So I think we can lend a very good hand to NIDM if you want to plan to do something in this western part of Madhya Pradesh in the vicinity of Vikram city area or so. So once again, I thank you. Without taking much more time, I thank you NIDM, particularly the Dr. Haldar, and I am proud to say that he is also one of the alumni of Vikram University, and he also had a very good positions at remote sensing and all that. Our students have been getting benefited from him from since long time, and in future also I think that he has come forward to help his alma maters, he help his department and all that. So though in NIDM I had been interacting from long time, but in different way, not in this seminar symposium way. So I think like that as a director general, I had to go here and there, a lot of meetings and so and so. But now as a responsible teacher here and administrator here, and on behalf of Vice Chancellor, I invite the NIDM to come guide us, suggest us, have a good plan for this area. We will have all sort of support and all sort of what you call manpower we can provide you. Thank you very much, Haldar Sahab. Thank you very much, Professor Surya Prakash, and thank you very much, NIDM, and thank you very much all the participants, listeners, and panelists. On behalf of Vikram City, I thank you one and all of you. Thank you very much.
Okay, sir. Thank you very much for your useful talk. And for your information, sir, I want to add or I want to share that already now it is stopped the face-to-face, but 10 days back we had a plan in Bhopal, face-to-face training associated with the NDMA, that is a state MP SDMA, but it has been stopped. And our nodal one coordinator is there, Professor Asutosh Mohanty, and we are coordinating them. And for each, not only MP, in other state also. And whenever some problem is there, our Surya Prakash is in a lot of committee, he is taking care. And also for the university benefit, we are there, sir. And one, we have opened INDRR. While on the inaugural session, I was highlighting, now that I will request to the VC of the university that immediately you should be member of that group. And lot of information they will get, and lot of time to time, lot of improvement that your students, your faculty, they will be benefited from this MOU. That is because some sort of MOU, but I'll provide your number or your coordinator number to the IUIDNRR, that who is there, the in charge. I will tell her, he will be, it will be incorporated. And accordingly, the rest of the things, and a lot of things that for the university side, it will be going on. And from our, not only your side, from our side as well as from our PM, what he wants, that university and young generation should be benefited, and they should be contribute for this disaster. Okay, thank you very much, sir, for your sharing us during the very quick session. Now, from as far as my is concerned, I'm from the Adaptation, definitely I'm always there for the university to wherever it is required, I'll be there, no problem. Now, dear participant and our the dignitaries, it is the time for our this vote of thanks. And of course, no problem, that we have conducted successfully the 3 days training, and we have started from the COVID management, this Omicron, another Omicron activity, and what are the needed and what are the history, all the things we have started. And after that, we have added a lot of natural disaster courses. But of course, this time biological disaster and chemical disaster, due to lack of time, we could not incorporate. But however, it is a very successful topic, and it has been covered, most of the say landslide, earthquake, and this innovation DRR, that innovation DRR and resilience, and for flood, Dr. Jyoti had talked nice. And similarly for the space technology, that from NRSC there. So we have covered at least to the basic things for your students and for the other participant who was regularly joining, sir. Now we will try to do some more in future also. And so in this aspect, I want to put that our executive director, who is always inclined for us and to conduct the successful programs and to add new universities, and wherever not a single university, all the universities should be benefited. For that, his motive is there, and always he is supporting us. For that, sir, we are greatly thanks to you, to our ED, NIDM, and also this VC, that Bikram University, Ujjain, who has given kind permission, and he was here personally to share the dais, to benefit the students. He want to talk a lot to the students and for the faculties and other participants also. So for that, sir, we are also thankful to him. And Professor Verma, he is there on behalf of VC. Today he is representing. And sir, I personally, and on behalf of Institute, it is a heartfelt thank to you. And our Professor Surya Prakash, always he is busy, obviously, but still he will not forget to join. Even in mobile also, he used to give time to put certain words to motivate the program in time and properly. So, sir, thankful to you also. And our rest of the panelists and our colleague from this NIDM, I put my thanks and I am applauding to them for their support. And the participant always there. I have seen a lot of good participants are there, professor and doctorate persons are there. I cannot recall the name, but for my program, they are always coming. So I am thankful to them, and not only them, other participants also, it is thankful to them. This time we have a very good number of participants. So for that, and I put my heartfelt thanks to the participant also. And always I'll request, so they should share if that whenever they will get time. And I used to highlight them through the NIDM portal as well as a personal mail. And so I will request in future there on 27th again, that is a very eminent speaker will be there. IIRS, Indian Institute of Remote Sensing Director will be there on environmental hazard. He'll speak, and one professor, renowned professor, he's from Arctic, that he has been his experience. So he'll speak on 27th in the morning sessions, 11:30. So presently, I'm thankful to you and also our this IT team, NIDM. They are supporting, not for the small thing, lot of things they are doing. That's why this program is successful. So I put one to all whose name I have I put forward, or still then lot of names are there. I cannot tell, keeping in view of time constraint. So I put my thanks, heartfelt thanks to all of you. Now, dear participant and my professor, I'll put my overall thankful for the successful completion of this training program. It is. Okay, sir. Thanks to you, and we'll take leave.